This video will be about processed data. So remember when we take notes in my class, we are going to use a new piece of lined paper each time. We're going to write the date and then any information that is on the slides in red needs to go in your notes. So please keep in mind that you may need to pause this video to write notes. Just pause the video, write down what you need to write, and then come back when you're ready. So here's what we're going to find out today. We're going to find out what is processed data. What does a processed data table look like? What are some ways that data can be processed? And what is an example of a processed data table? So what is a processed data and what is processed data and what is a processed data table? Well, processed data is data that has been changed in some way after the lab. So maybe you're finding the average or a percent. Processed data is different than raw data. Raw data is what you collect during the lab. Processed data is whatever you do to the data afterward. Oftentimes we need to process our data because it doesn't make very much sense to us in its raw form. So by calculating the average or calculating percentages, we can find meaning in numbers that wasn't there before. So that's why we process data. So here is an example of what a processed data table might look like. This is a template, so we're going to draw like the outline, and then later when you need to make your own processed data table, you'll just substitute independent variable for whatever the independent variable is for your lab, dependent variable for whatever the dependent variable is for the lab that you're doing. So we're going to start with that kind of lopsided T-chart, which would look very similar to the raw data table, but here's where things get different. The independent variable is going to go above the line, and the dependent variable is going to go right next to it. And I included the word processed here. You will see when we do the example what you'll replace that with. You're not going to actually say the word processed. You're going to explain how you've processed it. That's what goes there. So below that, we'll put the control and then change number 1. If you have more than one change, you will put that below change number 1. Notice that there's not any trials here. It's because we will have processed the data, so we will have made some meaning out of the trials, and now we're just looking at, okay, what do these numbers mean in relation to our control and our change? How is our dependent variable being affected by our independent variable changing? So there's a couple ways to process data. The easiest one probably is to just find the total. You can also find the average. You can find the net change, which is where you subtract the initial value from the final value. So if you wanted to know, for example, how much weight something has gained, like if you want to test the absorbency of sponges or whatever, you would take the mass of the sponge before you get it wet, soak it, take its final mass, and then you can calculate the change by subtracting. So you would subtract off the weight of the sponge, and you would know exactly how much water had been absorbed. That's a net change. And then finally, percentage. You're familiar with percentage from math class or from your grade. 93%, 25%. Sometimes that can be helpful, especially when dealing with people and opinions. 23% of people prefer red jelly beans. 12% of people prefer yellow, and so on. So this is not all of the ways that you can process data, but these are probably the most common and the ones that we'll use the most often in our science class. So let's take a look at an example. Bitmoji Ms. Jung is back at it again, and she is wondering if changing the circumference of, which is the distance around, a soccer ball will make it so that she can kick it farther. So in our last video, we figured out that our independent variable is the circumference of the soccer ball, the distance around. Its unit would be centimeters. The dependent variable is the distance that the ball is kicked, and that unit would be meters. So we're going to use that independent and dependent variable to help us make our processed data table. So this is the raw data table, and we did the experiment, so now we have data. So I have input that in our raw data table, and now I'm going to think about the data. And it seems to me that the average is going to give us the most useful information. Net change doesn't really make sense. A total wouldn't give me a lot of information. And I don't want to do any percentages because I don't think that would help make sense either. So I think average is going to give us the most information. So I'm going to process my data. So to calculate the average, I'm going to take each one of these values and add them together to get 11.7. And then I'm going to divide them by the total number of numbers that I have. So I had three values, 3.9, 3.8, and 4.0, three values. So I take 11.7 and I divide that by 3, and I get 3.9. For my second set of data for the 70 centimeter ball, I take my three values, I add them together, I get 9.4. I divide that by 3 because I have three values here, and I get 3.13 repeating. So I rounded that to 3.1. In my class, and your teacher might be different, but in my class, the 10th place is fine for data. You can round to the 10th place. I don't want you taking it all the way out to like the 100,000th place. Just the 10th place for my class is fine. So now I'm ready to process my data table because I have data. Or now I'm ready to make a process data table because I have processed data. So again, I'm going to put my independent variable here, which is circumference of the soccer ball. I'll put my dependent variable here. And this is where I'm going to change that word process. I changed that to how I process it, which is the average distance the ball is kicked in meters. I'll put my two values for the soccer ball, which is 65 and 70. And then I will also add my title. So circumference of the soccer ball in centimeters versus the average distance the ball is kicked in meters. And now, if I remember my data, I'll put my 3.9 here, and I'll put my 3.1 here. Notice that I don't have centimeters here or here, and I don't have meters here or here. And that's because in a data table, you do not put units in the body of the table. This would be the body of the table. You only put numbers. Units go in the headings, here and here, and then also they show up in the title. This unit here, when it's up in the heading, applies to everything below it. And this unit here of centimeters applies to everything below it. That's how you read it. So that is an important thing to keep in mind. You do not put any units inside the body of the data table. All right, so what did I learn today? I learned the definition of processed data. It's data that I have changed somehow by doing some mathemagic to it. I have looked at and know how to make a process data table template. I thought about ways to process data, the total, the average, the net change, and percentages. And then I looked at an example of a process data table and went through that with Ms. Jung. So now I should be able to go out and do it on my own. Thanks so much for watching, and enjoy the rest of your day.